Hello, I'm John Anrukin Hoveliana, and in this video, we will solve problems related to empirical formulas. This is part of Day 1, Physical and Chemical Principles of the Chemical Engineering Board exam. This topic is under Analytical Chemistry. So, for question number 4, determine the molecular formula of a certain chlorichlorinated biphenyl if it is 39.94% carbon, 1.12% hydrogen, and 58.94% chlorine, and the molar mass is 360.86 grams per mole. The choices are letter A, C14H8Cl16, letter B, C12H8Cl4, letter C, C10H8Cl2, and letter D, C12H4Cl6. To start this problem, we first need to calculate or determine the molar mass of the individual elements. So it's either we memorize the molar mass of the common elements carbon, hydrogen, and chlorine, or determine them from Perry's Chemical Engineering Handbook. The molar mass of the individual elements are carbon, 12.01 grams per mole. For hydrogen, this is 1.01 grams per mole. And for chlorine, this is 35.45 grams per mole. To solve problems related to empirical formulas, we can first set convenient bases. For example, let's have a basis of 100 grams of this compound. And assuming that the composition is on a mass basis, if we have 100 grams of the compound, then it follows that we have 39.94 grams of carbon, we have 1.12 grams of hydrogen, and 58.94 grams of chlorine. And then, we divide the respective elements by their molar mass to calculate the amount of moles in our 100 gram basis. For carbon, we divide 12.01 grams of carbon per mole of carbon. For the next part, we divide 1.01 grams of hydrogen per mole of hydrogen. And lastly, for chlorine, we divide 35.45 grams of chlorine per mole of chlorine. So we can determine respective amount in moles of each element in our basis of 100 grams. So we cancel grams of carbon, grams of hydrogen, and grams of chlorine. So 39.94 divided by 12.01 gives us approximately 3.32556 moles of carbon. Next, 1.12 grams of hydrogen divided by 1.01 grams per mole, we have around 1.10891 moles of hydrogen. And then lastly, 58.94 grams of chlorine divided by 35.45 grams of chlorine per mole of chlorine, we have 1.66262 moles of chlorine. With respect to the ratios of the element with each other, we can somehow write C 3.32556, H 1.10891, Cl 1.66262. And then, we divide all the subscript by the lowest value. So comparing these three values, the lowest number is 1.10891. So we divide 1.10891 to all the subscripts, and we will have C3 H Cl 1.5. We can still increase the ratios so as they become integers. So this becomes C6 H2 Cl3. So this can be considered as our empirical formula. since we are determining the molecular formula, we need to check first the molar mass of our empirical formula. So for C6H2Cl3, the molar mass of the empirical formula is 6 carbons, so 6 times 12.01 grams per mole, plus 2 hydrogens, 2 times 1.01 grams per mole, plus 3 chlorine atoms, 3 times 35.45 grams per mole. So the molecular weight of our empirical formula is approximately 180.43 grams per mole. However, from our given, the molar mass is 360.86 grams per mole. So we need to multiply N to calculate 360.86 grams per mole. So this N here will be multiplied to each of the subscripts of our empirical formula. So calculating N, 360.86 divided by 180.43, our N is equal to 2. So we multiply 2 to these subscripts. So finally have C12H4Cl6. And this is our molecular formula. From the choices, this is letter D. For our next problem, a solid was analyzed to be 42.10% carbon, 6.49% hydrogen, and 51.41% oxygen, with a molar mass of 342.34 grams per mole. Determine its chemical formula. Letter A, C10H14O16. Letter B, C12H22O11. Letter C, C16H12O6. Letter D, C11H18O12. To solve this problem, like in the previous question, we first take note of the required molar masses of the elements. In this case, we need the molar masses of carbon, hydrogen, and oxygen. For carbon, it is 12.01 grams per mole. For hydrogen, it is 1.01 grams per mole. And for oxygen, this is 16.00 grams per mole. Let's take a basis of 100 grams of the compound. From the given analysis, it follows that we have 42.10 grams of carbon, 6.49 grams of hydrogen, and 51.41 grams of oxygen. Individually, we divide the molar masses. So, for carbon, we divide by 12.01 grams of carbon per mole of carbon. For hydrogen, we divide 1.01 grams of hydrogen per mole of hydrogen. And for oxygen, we divide 16.00 grams of oxygen per mole of oxygen. The units, grams of carbon will cancel, grams of hydrogen will cancel, grams of oxygen will cancel. So in our basis of 100 grams of compound, we can calculate the amount of moles of carbon, hydrogen, and oxygen. So calculating for carbon, we have 3.5054 moles of carbon. For hydrogen, we have 6.4257 moles of hydrogen. And for oxygen, we have 3.2131 moles of oxygen. We can divide these three values by the lowest number. The lowest number is 3.21 31. So we divide these three numbers by 3.21, 31. So the values become 1.091, 2, and then 1. At this point, we can assume a formula of C 1.091 H2O subscript 1. Determine the molar mass of this chemical formula and multiply by N to match the given molar mass. So the molecular weight of this tentative chemical formula is 1.091 times molar mass of carbon, 12.01 grams per mole, plus 2 hydrogen atoms, 2 times 1.01 grams per mole, plus 1 oxygen atom, plus 1 times 16.00 grams. So calculating the molar mass of this tentative chemical formula, we can calculate 31.12291 grams per mole. So we need to determine the value of N that we need to multiply to this value so that it matches 342.34 grams per mole. So N is 342.34 grams per mole divided by 31.12291 grams per mole. And this gives us a number of 11. So multiply 11 to each of these subscript, and we will have C12 H22 O11. And this is our chemical formula. From the choices, this is letter B. So for our last problem, question number 6, determine the empirical formula of a ceramic sample if it contains 14.21 grams of molybdenum and 8.31 grams of silicon. Letter A, MOSI2. Letter B, MOSI. Letter C, MO3SI2. Letter D, MO2SI3. To solve this problem, we first take note of the molar masses of molybdenum and silicon. From the periodic table or the Paris Chemical Engineering Handbook, molybdenum has a molar mass of 95.95 grams per mole, and silicon has a molar mass of 28.09 grams per mole. We don't need to set a basis because we are given the respective amounts of molybdenum and silicon. So we need to convert these respective masses to their moles. 14.21 grams of molybdenum divided by its molar mass, 95.95 grams of molybdenum per mole of molybdenum, and similarly 8.31 grams of silicon divided by its molar mass, 28.09 grams of silicon per mole of silicon. We can cancel grams of molybdenum and grams of silicon. So for the first part, 14.21 divided by 95.95 will have 0.1481 moles of molybdenum. Next, 8.31 grams of silicon divided by 28.09 grams per mole for silicon, we have 0.2958 moles of silicon. Like what we did from the previous problems, we can divide by the smaller number. In this case, divide by 1481 divided by 0.1481. This is equal to 1 and this is equal to 2. So these are the subscripts respectively for molybdenum and silicon. So our empirical formula for this problem becomes MO subscript 1, silicon subscript 2, or MO Si. From the choices, this is letter A. So that's it for our questions on empirical formulas. If you enjoyed this video, please like and subscribe. See you in our next video.